In previous lectures, we discussed the algorithms like log, difference of Gaussian, and the determinant of Hessian to compute blobs in images. Furthermore, we discussed the image pyramids, Gaussian scale space, and the concept of octaves. We also saw that how SIFT algorithm uses the concepts of octave and combines it with the difference of Gaussian, and then also uses the determinant of Hessian as a way to filter out the weak or the false positive responses in the determinant in the difference of Gaussian response of the image. So in this lecture we are going to discuss all three methods: the Laplacian of Gaussian, the difference of Gaussian, and the determinant of Hessian methods, the algorithms, the fundamental algorithms that we discussed in the previous lectures, to show you the output of these algorithms for the blob detection in the sample image. So here is our input image. And for the purpose of detecting blob, we convert this input RGB image to a grayscale image. So the sigma naught value that we used was 1 and our value of K was 1.8, and then we incremented the sigma values like sigma naught, K, sigma naught until it exceeded the value of 10. So we had 6 scales where we computed the blob. So here the purpose of showing the output is just to let you know that you can implement all the algorithms that we had discussed previously to take blobs in images. And definitely you can combine these algorithms with the concept of octaves and the other some of the techniques that we discussed previously to get more robust results. And you can select the threshold values appropriately as well to make your algorithms more robust. But here we are just showing like how you can implement the concepts that we have discussed previously to implement your own blob detector from scratch without any dependence on any library for that matter. And then you can combine, take the idea of octaves and do even much better than the results that we are showing over here. So here is the output of log. So this is a log-based blob detection, and you can see that it generated many of the blob responses over here as well as over here. Furthermore, here is the output of difference of Gaussian. So as you can see, the for the same parameter values over here, the response of dog was better as compared to that of log response, where it generated too many responses on top of the vehicle. However, here we can see that it gave many of the false positive responses along the edges. But again, like since we are using the same parameter values for both the algorithms, we are getting these kind of results. We can just select different values and we can get different results as well. And perhaps better result for the difference of Gaussian, where we can suppress the amount of false positive responses. Finally, here we have the determinant of Hessian, and we can see that the for the blob responses on the vehicle, we can see that the quality of blobs have slightly improved. Here also, I think determinant of Hessian is the only detector which is showing these buffaloes as blobs in images. And you can see there are very few false positive responses for determinant of Hessian, and thus you can see rather than using this as a primary blob detector, we can perhaps use it to suppress these false responses, the output of the difference of Gaussian. And this is exactly what was used in the SIFT algorithm as well, which we discussed in the previous lecture, that SIFT uses the determinant of Hessian as a filter to filter out the edge responses of the difference of Gaussian, and also the weak or false positive responses of the difference of Gaussian. So this concludes our lecture on blob detection and our lecture on the feature detection at large.